So let's talk about the uniform probability distribution, okay? Now there are many ways we can define or describe the uniform probability distribution, but the way that I'm going to define it or help you understand it is an initial description. A uniform probability distribution is a probability distribution, and it's one way of looking at it is a continuous probability distribution in which the probability is always the same for any two internal intervals of the same size. So think of an internal interval. It's inside. So like, let's say, remember the example that we had in the last video was wrist length. And we had wrists that are between 5 inches up to 9 inches, okay? And so any interval that runs smaller than 5 up to 9 would be an internal interval. Now it can include 5. So for example, going 5 up to 6 would be an internal interval, okay? So here's an example. Note that the internal interval 5.5 up to 6.8, it is 1.3 units long. How do we know that for sure? Well, we can just do 6.8 minus 5.5. 6.8 minus 5.5 is 1.3. So the width or the range of this internal interval is 1.3 units. Similarly, the internal interval that goes from 7.2 up to 8.5 is also 1.3 long because 8.5 minus 7.2 is also 1.3. So 5.8 to 6.8 or 5.5 to 6.8 is the same size as 7.2 up to 8.5. It's the same size internal interval. So if our probability distribution is uniform, then let's say that we knew that the probability of going from 5.5 up to 6.8, what this means is, what does this mean, the probability of 5.5 up to 6.8? The probability that x is greater than 5.5 but less than 6.8. That's the probability that x is between 5.5 and 6.8, okay? So what that's saying is, what's the probability of randomly selecting any adult and they would have a wrist length between 5.5 inches and 6.8 inches? And suppose that that probability was 0.325. Then in a uniform, if it was a uniform probability distribution, then the probability of randomly selecting an adult whose wrist size is between 7.2 and 8.5 would also be 0.325. It's the same probability. And that's what we said. A uniform probability distribution is a probability distribution in which the probability is always the same for any two internal intervals of the same size. And so if this interval is the same size as this size, then the probability is the same as the probability, or the probability of the first one is the same as the probability of the second one, okay? So let's do an example here. Suppose a continuous random variable x follows the uniform probability distribution with a range of 19, and it runs from 63 up to 82. And if we did 82 minus 63, 82 minus 63 is 19, and we'll get to that later, okay? And suppose that the probability that x is between 70 and 75 is 0.263. Okay, so how wide is this internal interval from 70 up to 75? Well, we can just do 75 minus 70, and that's an internal interval of 5, okay? And so this is an internal interval of 5. Well, then if we were to then ask, well, what's the probability of x being between 76 and 81, well look, 81 minus 76 is also 5. 81 minus 76 is equal to 5. And therefore this internal interval is the same as this internal interval, and since it's a uniform probability distribution, then the probability right here is going to be the same, 0.263, okay? 0.263. Well, now this one says, well, what's the probability of it being from 64 up to 74? Okay, well, that's a good question. Well, 74 minus 64 is equal to 10. That's not the same as this one. However, it is uniform. So because it's uniform, since 10 is double 5, our probability is going to be double the probability. So it's going to be 0.263 times 2. So let's do that. 0.263 times 2, and that's going to be 0.526. So the probability here is going to be 0.526. And how do we know that? Well, because 64 up to 74 is the same thing as saying 64 up to 69 plus 69 up to 74. And so we have a 5 interval and another 5 interval. That's 2 5 intervals. So we would have 2.263 times 2. One for this one, 0.263, and one for this one, 0.263, for a total of 0.526. The same thing happens here. 65 up to 80, that's 15, because 80 minus 65 is equal to 15. And 15 is 3 5s, so we would do 0.263 times 3. So we'll do 0.263 times 3, and that gives us 0.789. 0.789. Okay? And so this is just sort of an introduction to the uniform probability distribution. Now, all continuous random variables have what's called a probability density function. Okay? It's basically a graph. It's a function that can be graphed on the coordinate plane, like this one down here, and they have varying shapes. And the uniform probability distribution has a very simple probability density function. Its probability density function is a constant function. Now, I want to remind you that a constant function is a function whose graph is a flat line. Okay, there's no x's in the function. It's just a constant number. Okay, and the uniform probability distribution has its probability density function, sometimes called a PDF. Okay, its PDF is constant. That means it's a flat line. And here is the formula. Write this formula down. The formula for the probability density function is f of x is equal to 1 over b minus a, where b is the maximum value. So b is the higher value on the interval. So here the higher value is 9 inches. If you look down here on this graph down here, this is the wrist size, 5-inch wrist versus 9-inch wrist, right? B is the maximum value, which in this case is 9, and A is the minimum value of the range, and in this case that's 5. So we would put a 9 here, and we put a 5 here, and if you look down here, you can see it. F of x is equal to 1 over 9 minus 5, and 9 minus 5 is 4, so we have 1 over 4. So for this wrist size question or this wrist size situation, if it is a uniform probability distribution, then its probability density function is going to be f of x is equal to 1/4. Okay, and then if we want to talk about the probabilities, so look at this. The probabilities are simply the area of a rectangle. Let me show you what I mean. If we go up from 5 here, what we do here is we essentially create a rectangle. And the area of this rectangle, what rectangle, Mr. Ryan? This rectangle, look. The rectangle has one side that is the probability distribution. It has one side that's the x-axis. It has one side that's the minimum, and it has one side that's the maximum of the situation of the range, okay? And this area here is the probability of selecting a particular unit from the population having a specific value, like 5 inches or between, between 5 inches up to 6.3 inches or something like that, okay? So the probability of the random variable x having a particular value is determined by the area of this rectangle. Note that the height of the rectangle, okay, so the distance from here up to here is equal to the probability density function. So the height here, the height of this rectangle is 1/4, and the length of the rectangle is equal to 9 minus 5. And so 9 minus 5 is equal to 4. And so this is a rectangle with a height of 1/4 and a width or a length of 4. And if we were to do area is equal to base times height, okay? And the base, we just said, is equal to 4. The height is 1/4. And so area is equal to base times height. So that's going to be equal to 4 times 1/4. And 4 times 1/4 is equal to 1, which makes sense because we said that the probability of this area would be equal to 1. But what if we were to take a different interval? What if we took an internal interval that was not 5 up to 9? What if we wanted to do 6 up to 8? Let's see, 8 is here, 6 is here. Well, then we would have a smaller rectangle. And this rectangle has a base of 2 and a height of 1/4, height of 1/4, always a height of 1/4, and 1/4 times 2 is equal to 1/2. So this would be a probability of 0.5. All right, so now here's where we learn how to answer math questions. This is the part of the video where we learn how to answer, well, how can I do my homework? This is where we learn how to do your homework, okay? So let's say that we have a random variable x, and it's best described by a uniform probability distribution, okay? And it has a range from 9 up to 16, okay? And so we would call this 9, we would typically refer to it as A, and this 16 we would typically refer to as B, okay? And so the first thing we're going to say is, well, what is the range of the probability distribution? Well, the range is calculated by B minus A, okay? So the range is going to be calculated as 16 minus 9, and 16 minus 9 is 7, and therefore 7 is the range of this uniform probability distribution, okay? And so now we want to know, well, what is the probability density function? What is the PDF, okay? Remember, the PDF for a uniform probability distribution is f of x is equal to 1 over b minus a. And in this case, b is 16 and a is 9. And so our PDF in this case is f of x is equal to 1 over 16 minus 9, and 16 minus 9 is 7, and so the PDF is 1/7. The PDF in a uniform probability distribution is always a fraction, unless it's 1. Sometimes it equals 1, but in most cases it's a fraction that winds up being 1 over the range. So 1 over the range is typically our probability density function, okay? And so now let's say we want to answer the question, well, what is the probability that x is less than 11.2? Okay, well, here's what we need. The probability density function is going to be the height of the function. And remember that the height is the probability density function times the base of the function. And the way that we get the base is we do basically the larger interval, the maximum of the internal interval minus the bottom. Now, when we do a less than, you might say, well, this is not a between. This says x is less than 11.2. Well, saying that x is less than 11.2 is the same thing as saying that x is between 9 and 11.2, okay? This is the exact same thing, because look, the lowest end is 9, okay? So saying x is less than 11.2 means that x is between 9 and 11.2, okay? So the base is going to be equal to, in this case, so the height is the probability density function, 1/7, and the base is always going to be equal to the larger number in the interval, larger minus the smaller number in the interval, okay? And so let's see what that looks like when we're doing homework. So this is going to be equal to the probability density function, 1/7, times the larger number, 11.2, minus the bottom of the range, which is 9. And so this is now going to be 1/7 times 11.2 minus 9. So that's going to be 1/7 times, and if we do 11.2 minus 9, 11.2 minus 9 is 2.2. And so we have 2.2. And so we have 1/7 times 2.2. All right, so we can do 1 divided by 7. Now, let me show you, I don't know what kind of calculator you have. Chances are you're going to have to do parenthesis 1 divided by 7 and then close the parenthesis. And then times 2.2, okay? And then what we get is 0.314. I'm going to go to 3 decimal places here. Actually, I noticed in some of the homework assignments, they require you to go as many as 4 to 6. Let's go out to 6 here. So we'll do 0.31428. This 7 is going to turn this 5 into a 6. So we're going to say 0.314286. 0.314286. So equals 0.314286. And that is the probability that x is less than 11.2, okay? So now let's do the probability that x is larger than 13.1. Well, what does larger than 13.1 mean? Well, that means above 13.1, but smaller than 16. It has to be smaller than 16. So 16 is the top. This is very similar to saying that x is between 13.1 and 16. So we're going to have to ultimately do 16 minus 13.1 in our calculation. Okay, so erase this, and here we go. So we're going to do the height. It's going to be 1/7 times 16 minus 13.1, and that's going to be 1/7 times, well, what's 16 minus 13.1? All right, well, 16 minus 13.1 is 2.9. Okay, so 1/7 times 2.9, and let's see what that is equal to. That's going to be equal to 1, well, remember, I forgot, parenthesis, 1 divided by 7, close parenthesis, times 2.9, and that gives us 0.414286, 0.414286, 0.414286, and that is our probability that x will be greater than 13.1. Let's do one more here. The probability that x will be between. Now you may ask yourself, well, this one says or equal to, and this one does not say or equal to. That is totally irrelevant. Remember, with a continuous random variable, equal doesn't mean anything. So less than or equal to is the same in these situations as just less than. they mean the exact same thing in when we're dealing with a continuous random variable, okay? And so we're going to need to do the height, which is 1/7, and now we're going to do the difference between 14.8 and 12.7. So we're going to do 14.8 minus 12.7 equals, okay, well, what's 14.8 minus 12.7? Okay, 14.8 minus 12.7, and that's 2.1, okay? And so this is going to be 1/7 times 2.1. Let's do that in the calculator. Parenthesis 1 divided by 7 times 2.1, and that gives us 0.3. Okay, so our probability is just 0.3. Notice there were no decimals here, right? That's simply because 1/7. This is the same thing as saying 21 divided by 70. It would be the same, and since 21 is divisible by 7, we wind up with a terminating decimal. Okay. All right, so that's basically the idea of how to calculate probability and how to identify the probability density function and how to identify the range. And now we only really have one video left, and that's how to identify the mean and the standard deviation of a uniform probability distribution.